Dr. JP sir, please start.
Okay, ma'am. Good afternoon, participants. Good afternoon to Professor Jeevan V. Tirki who is from IIT BHU. Welcome to all. Actually, this is our second last day, means 20th day of 21-day national workshop on recent advances in agricultural engineering and technology for doubling farmers' income. This is our an effort to for farming community for enhancing. Not we are actually assume doubling the farmers' income if we can do something for farming community. So this is an effort in that direction. So for today's talk, we have a very young professor of BHU Varanasi. So for his brief introduction, I would like to call our course director, Dr. JP Rai sir. Please come, sir, and introduce our today's speaker, Dr. JP Rai sir. Please.
So welcome all. A very good afternoon to everyone here. Today's resource person is Dr. Jeevan V. Tirki. He is an associate professor in Department of Mechanical Engineering, Indian Institute of Technology, BHU, Varanasi. He graduated in Mechanical Engineering from Government Engineering College, GGU, Bilaspur in 1998. He did his PhD at Indian Institute of Technology, BHU, Varanasi, formerly IT BHU in 2008, under the supervision of Professor H.N. Gupta in the research area of internal combustion engine. Dr. Tirki bears a very good academic record, and he has published more than 65 articles in peer-reviewed international and national journals and conference papers. Just a minute. I am being disturbed by the permission for admission by the participants. So please forgive me for a second. Since so many people are joining right now, my window is keeping very frequently. So Dr. Tirki has guided, just a minute. It has almost become impossible to read even his biodata. So many participants are joining. In his supervision, he has guided more than 30 UG students, UG projects, and 35 master's theses. In his supervision, 4 PhD scholars have completed their thesis, and 2 are working right now with his team. He has developed an IC engine lab and has developed courses related to alternate fuel for transportation and energy management. He has conducted several national and international conferences and short-term courses for teachers and students at national level. Dr. Tirki is also technical chairman of Vehicle Condemnation Cell of BHU. He is a life member of the Institution of Engineers, India. He was the member of Energy Management Sectional Committee, MED 39, Bureau of Indian Standards, New Delhi, and member of Executive Council, Rajiv Gandhi's Pradyogiki Vishwavidyalaya, RGPV, Bhopal, in Madhya Pradesh. He has worked as a team Averera of IIT BHU, participating in EcoShell Marathon Asia in Singapore from 19th March 2017, and achieved energy efficiency of prototype battery electric vehicle 131.8 km per kilowatt hour. He has also worked as a consultant to many industries for industrial problems. He has worked on the project of the Center for Energy Resource and Development, CERD, and CST UP Incubation Center for Grassroots Innovators. He is the mentor and co-PI of the development of battery-operated geared e-bike, high-speed cycle, and garbage collection rickshaw under the CST UP project. Recently, he is working on a project on waste valorization. He has very extensive administrative experience at the institute level and at the national level. His current research work is associated with renewable energy, life cycle assessment, LCA, waste to energy through gasification, internal combustion engine, SI and CI, experiment in stimulation, alternate fuel for an engine, Miller cycle based overexpanded engine. So, with all these qualifications, we have today's resource person, Dr. J.V. Tirki. So now I request Dr. Tirki to please proceed with his deliberation. Dr. Tirki, sir.
Okay, thank you, Dr. Rai, for introducing me in a short and a very long length. Okay, thank you so much. So, is my voice is audible to all of you?
Yes, sir.
Okay. So today's topic of this workshop is valorizations of agriculture waste biomass to engine applications. Valorizations is basically value addition. So value additions of agriculture waste biomass to engine applications. After engine applications, many other equipments or any other elements can be run. Okay. So what is the present scenario over 2035? If we going from 2000 to 2035, and this I took from the 2017 Energy Outlook. Here we can see around 50 or more than 50% of the energy is being required till 2035. So there is transportation and the non-transportation is also there. And this is corresponding to the per day. So this much worldwide million of barrel of energy is required per day. And another slides you can see there is another fuels are there, biofuels and gasoline fuels and the crude oil. But the crude oil is been very high in comparison to other types of the fuels. But in the 2015 to 2035, it has been predicted that it could be reduced. And other types of the fuels could be encouraged to utilize so that our energy demand could be fulfilled. In the transportation sector, if you'll go, then we can imagine by 2035, in the different area by regions, non-OECD and OECD, electric vehicles are very small now, but the conventional car maybe it will around 1.6 billion of the vehicles could be reached at 2035. However, if we consider for the electric vehicles or electric cars, as main things are there, it's packaging cost. So battery packaging cost is very high in 2015, but it seems to be reduced, and it could be below $200 per kilowatt hour. So this would be the packaging cost in nearby 2035. One another thing is that which is our very requirement in side by side, as we need the power requirement, but we need to reduce the carbon dioxide also. And how we are increasing the carbon dioxide? And it is predicted that 2040 it will be reached to the 20,000 megaton of equivalents. In global CO2, which will be more than 35,000 ton watt hour. So this way we are increasing the CO2. This is very unfortunate that whatever the energy we are getting from the earth, and we are finding the petroleum fuels, and when we burn it, carbon dioxide releases. And one thing is that whenever the engines is very efficient, then carbon dioxide release is very high. And means when the carbon dioxide is very high from our engines or any movable vehicles, it one hand it shows that the engines is inefficient working. But on the other hand, if this is reducing, then we say that engine is not working efficiently. That's why the CO and other things, other emissions are also coming. So with respect to pros and cons, we can see that CO2 is always being increasing day by day, and this will rise 2040 very high. So what is the energy resources what we can have from the yesterday to the tomorrow? We were taking the sun, wind, water, biomass, human and animal muscle power we were using. Okay. And here 70% of the all work human muscles were using, and majority 30% domesticated animals were using. But today, what we are doing, we are using coal, fossil fuels, natural gas, electricities, and these are the different ratios. And these all are non-renewable. We cannot reverse it. We can reverse it with a very long time. It will take more than 200 years and all. So it is not renewable. But tomorrow, what will it doing? Again, the yesterday is coming. Sun, wind, biofuels, biomass, nuclears, although it has to be taken in safety, and development of technology for use of renewable energy sources. So as per the agriculture purview is concerned, so what we are looking for, that if we are using the yesterday means of energies utilizations in the tomorrow, then the consumptions of today's coal, fossil fuels, natural gas, and other form of electricity through which it is coming, that could be reduced. If it has been reduced, then automatically the economic conditions will increase. So one thing is there, whenever we are using the renewable form of the energy, our economic growth increases. But one thing has to be added, it should be technologically interlinked. In the yesterday, what we are using, that was very much conventional what the village persons were using. But nowadays that has been very less, and that has to be upgraded in tomorrow by utilizing these all resources, that is sun, wind, biofuels, biomass, and nucleus. So this is for economic growth and sustainability, because coal, fossil fuel, natural gas, these all resources are in depleting order. This has been reducing. Some paper I have seen that coal is going to be reduced in India after 40 years. The coal is available. Surface coal is available for the next 40 years. Then what we'll do? Then either we have to shift for the renewable form of energy, or some other gasification systems, or the earth has to be digged more so that some more amounts of the coal could be utilized, so that we can fulfill the requirement of today's demand. So these are the basic scenario regarding energy resources. What are the other challenges are there? Has also been estimated that by 2060, global energy demand would have been doubled. So in the previous slides, I have told you that 20,000 billion joules is required. So this will be 20 to double, 40 billions will be required. 40,000 billions will be required per day. So this much energy is required. Another case is there. If the CO2 emission is increasing, then it will be difficult. And as per the agreement, in the Paris Agreement, it was said that the average global temperature should not be exceeded 1.5. 1.5 degrees Celsius. Maximum limit is 2 degrees Celsius. And corresponding to that, it should not be increased 2900 gigaton up to 2100 year. But still we are reaching 2014 to 19,000. 2014, 19,000 gigaton already CO2 we have emitted. So we are going in the very dangerous stages. Global mean sea level has risen approximately 0.19 meter between 19,000 and 2010 with the rate of nearly 1.7 millimeter per year. Every year, the sea level is increasing 1.7. National Ocean and Atmosphere Administrations, they have said that in 2100, this will be rise up to 2 meter. And when the Greenland ice sheet will be melt, then what will happen? The sea level rise will 6 meter. And while the Antarctica ice sheet will melt, then it will rise 60 meter. And these all are affected by, will be affected by your CO2 level, and which is the more causes for the global warming. So when the sea level will rise, what will happen? Coastal flooding will come up, erosions of the soils will go there, salt water contaminations of the fresh water supplies, increase in salinaries of the agriculture soil, and hurricane storm surge, etc. and etc. This will be the effect of global warming when CO2 level increases. Then very dangerous thing is there. Most of the Indian peoples or those in the worldwide, those who are in the coastal region, nearly 625 million people residing in low elevation coastal zone are at risk of exposure to this hazard of sea level rise. These all peoples will be very difficult to survive in their living space. So this is very dangerous what we are going today. One another thing is that global warming is caused by municipal solid waste. How much waste we are producing globally? So here you can see municipal solid waste generation corresponding to the land and requirement related to the and corresponding to the population's rise. So 2051, this per day, nearby 1500 municipal solid waste generated per day. So this is the worldwide scenario, how much municipal solid waste we are producing. And this mostly is being done from the city areas. Rural area, this is very less, but in the urban area, this wastes are becoming very high. So if you consider major cities in terms of the municipal solid waste generations, then here you can see in the last one here, this is Varanasi and Mumbai, Delhi, Bangalore, Hyderabad. So these are the different areas are there. So here you can see maximum percentage which is coming from, that is Bangalore. This Bangalore is 1850% with respect to 1999 to 2000. Maximum percentage is related to the Bangalore. Okay. And Mumbai, although Mumbai population is very high, 2019 to 2000, but here the municipal solid waste is very high corresponding to the Bangalore city. Municipal solid waste are these all things. I'm not going on details. That heavy metals are there, which creates the air pollutions, which creates the health hazards and skin disease and asthma and cardiovascular disease, respiratory infections. These all things are coming to this as pollutions is through the municipal solid waste. And this is this I have taken from the Journals of Cleaner Production. It is published in 2020. And similarly, if we want to convert this municipal solid waste, then these are the different stages are there. Some factors on the biomass residues. Previous cases, we have seen the municipal solid waste. And at the last, I will tell you how the municipal solid waste will be converted to the energies. So first of all, we are understanding what are the municipal solid waste and how much its availability. And when we convert this one, and what is the technology behind it, so that this waste can be converted to the energies. So first of all, I have introduced you about the municipal solid waste. What are the its ingredients are there, and what is the harms are there when it is disposed unwillingly and here and there. So this is the disposal techniques what we are processing for. Some facts on biomass residues. Now I am shifting to the biomass residues. There are many biomass residues are there. And as per MNRE 2015, it was reported that India is estimated at about 500 metric ton per year from considering agriculture and forest waste residues areas. So 500 megaton, metric ton per year. So this is the availability of the residual gases, residuals of products we are generating all over the India. The anticipated surplus biomass available is about 120 to 150 million metric ton per annum, which constitutes to a potential of about 18,000 megawatt energy. So if you convert this waste residues, then this could be able to convert 18,000 megawatt of energy. And some details are there. Biomass Atlas of India, type of source, agri residues, forest land, and wasteland. These are the different area. Biomass generations and biomass surplus is what we have, that 147, 100, 210. This is the kiloton per year. So that will be 147 megaton. So that is the availability of the biomass all over the India. So energy crops are crops specially cultivated to provide biomass. You all people are agriculture people, so you know this is better than. And biofuels are fuels produced from the biomass, usually of the agriculture origins. So from the agriculture origins, we find bioethanol, biodiesel, biogas, producer gas, and syngas. So these are all thermochemical transformations from the biomass. Bioethanols nowadays, 10% of the ethanols in the petrols has been mandatory. So if you go to the petrol tank and others, so they offer 10% ethanols to be blended in a petrol. So government is also promoting to use 10% of the biodiesels with the diesel, so that 10% conventional diesels could be saved. Similarly, biogas. This biogas is utilized when we are moving toward the CNG. In the daily, CNG buses are running. So this can be partially blend with the CNG so that at that particular amount of the CNG could be saved when biogas is blended in that particular proportion. Last one is the producer gas and the syngas. And this is also one of the important gases is there. This is also flammable gas. So this can be used. This is basically gaseous fuels which can be used either for the blend of the biogas, syngas, or in the pure form also it can be used. And one thing is that this could be utilized with the biodiesels also. This could be utilized with the diesel blendings also. So this is what I'm going to tell you. So my focus will be in place of bioethanol, biodiesel, and biogas, I will concentrate on the producer gas and syngas transformations from the biomass. And this biomass is not from the a genuine one, but this is from the waste biomass. So these are the different biomass are we have. Agricultural crops waste, forest wood residues are there, some animal waste are there, and some other plastic wastes and other things is also available as a residues. So major tree-borne soil seed for productions of the biodiesel in India. So if you are producing the biodiesel from the 7 different seed oil, then also it is very much benefit for the our agriculture people. And this is very much popular also from the beside the Jatropha, people are taking the neem oil, karanja oil, mahua oil, simaroba oil. So these all types of the oil seeds are efficiently converted to the biodiesels. So when you have the number of neem trees or the karanja trees or the mahua trees also there, then when you sell these seeds or you extract the oil from there, so the different industries are there, so they can purchase the oil from the agriculture sector and they can produce the biodiesel. So this is also one of the good source to enhance the economy of the agriculture sector or toward the villages area. So one paper I have published in 2021 that when you will have the mahua tree in 1 acre, how much energies could be produced and how much biodiesels could be converted from there. So this is very good. So this is also one of the important resources through which economic will be enhanced to the village peoples or the agriculture sector. So potential of the biomass residues, the dependence of the fossil fuels. However, the disadvantage has to be more concerned. Biomass has a low energy content compared to the coal and petroleum derived fuels. Intensive cultivations may stress water resources and deplete soil nutrient. It has high cost of transportations and pre-treatment. So these are the disadvantages which has to be overcome. So there must be balance between the food and the fuels. So conversion technologies from the biomass to clean fuels are these different. As in the previous classes, I have told you the last one is the biodiesel, bioethanol, producer gas, syngas, biocrude, pyrolysis oil. So these are the different oils are being converted from the biomass, and some raw oil from the different seeds. So these are the different conversion technologies are available in the market or in the worldwide also. So the red color is there, gasifications. On this area, I will mention about. So biomass is basically composed of carbohydrate polymers, that is cellulose and hemicellulose, aromatic polymers, and protein and fats, cellulose, hemicellulose. These are the difference. So when you are going for the hardwood, then it contains the lignocellulose, hemocellulose, lignin, and cellulose. So when the heat is applied to convert to the fuels, then at least it needs 500 degrees Celsius. And because it has the carbon, as we know that whenever the biomass is being pressed inside the earth, and that is staying in very long time, 100 year or the 200 years, and it is beneath the earth. And because of the carbons available in the biomasses, that is pressed condition inside the earth, and that converted into the form of the oil. So between the rock there is some oils, so that is basically called rock oil. The same fundamentals are also there. We have the carbon in the biomass, so whenever we burn it, then it gives the energies. And this all is been actuated by the sun, and because of the photosynthesis, this all carbon is been stored inside the uh, biomass. So before any gasifications or the any chemical properties or the transformations of the energies from the feedstocks, basic experimentations and property investigations is very important. So that is, one is called ultimate analysis and proximate analysis. So chemical engineering peoples and some agriculture peoples also, they identify this feature, that how much carbon, hydrogen, nitrogen, oxygen, and sulfur is there. And those biomass which have the high carbon and hydrogens are there, it is very much applicable either for the conversions of biomass to pyrolysis oil or for the gasifications. And on that other case, those biomass which contains more volatile matters and the carbon contents, it gives the more energies for the different purpose, and its high calorific values and the low calorific values, so that comes in the megajoule per kg. So heating value is more if the volatile matter or the fixed carbon is higher when you go for the proximate analysis. So these are the different biomass: corn straw, corn stalk, poultry litter, eucalyptus, oil palm pods, acacia wood, peanut shell, and these are the different biomasses also there. And similarly, the lignin and cellulose contents of particular biomass is also here. So that also you can have it. Physical properties of the different biomass feedstocks can be seen. Okay. So thermochemical conversions of the biomass is, there is three things are there. One is called pyrolysis, another is called gasification, third one is combustions. In the village area, we are using the combustions. The wood is being directly utilized for burning, and through that we are getting the heat energies. And gasification, combustion gases are there. So when we produce the gases, it can be stored and it can be transferred from one place to another places. So this will be in less weight in comparison to the wood stock, and this will be easy to transport. So similarly, pyrolysis, two things are there: charcoal and biofuels. So these all are the economic criteria to extend when we are utilizing the biomass to the market. We can sell it in terms of the charcoal, in terms of the biofuels, in terms of the combustible gases, or direct with the log of biomass. So these are the different criteria: what is called combustion, what is called gasification, what is called pyrolysis. The pyrolysis, wood to oil; gasification, wood to gas; and combustion, direct gas. So this is the key points through the thermochemical conversions of biomass has been conducted. So gasification is not new. It is developed in 1800s and since 1920s used many people for the gasifications. But in this time, the gasifications is been utilization of gasification is very much increased because fossil fuels degradations is been observed, and we want to reduce the consumptions of the conventional fuels. So that's why the gasification uh, technology is been very much popular, and it is going to be upgraded nowadays. So how the gasification has been done? So this video you can see. Is my voice is clear, right, sir?
Yes, sir. Your voice is clear, sir.
Okay, thank you. So here you can see the gasification from the agriculture waste is used as fuel for the gasification. So waste wood is been taken into the gasifier. Biomass is placed there, and in absence of the oxygens, or the limited amount of the oxygens is transferred there, and because of that some flame is been generated and it gives energies. And because the biomass are there, and that is in the contact of the low oxygen availability, so it produces unburned hydrocarbon and unburned combustion gases. So that is going to be transferred from other tubes, and it goes from the water coolant, because when the gases is been coming out from the gases, it is becoming very hot and it has to be cooled down. Some tar particles also coming from there, some ice particles also coming from there. So that way it has to be settled down and it has to be cooled down, so that the pure gases from the unburned biomass controlled combustions, this could be released, and the pure carbon monoxide, H2O, then CO, then CH4, and the N2 will come out from the blue regions, what you can see. So from here, this blower is going to be sucked, and from that filter, we can use as a producer gas or the syngas. And here the syngas is mentioned. This syngas is like a combustion fuel. It is basically combustion fuels, like a natural gases, like a LPG gases, but its calorific value is less. Only this is the demerit. So this can be stored and this can be transported from one places to another places. So this is the working style of the gasification. So there is gasifier which utilize the biomass, then we cool it, then we filter it, then syngas is coming out. Producer gas and the syngas both are little bit same. So some filter portions is called syngas. from the sorry, from the producer gases. So this is little bit chemical mechanism how the gasification has been done, and how the combustible gases it's been generated from the wood, and it can be stored in a different stove in a compressible or very good cell, high pressure cell. It can be transferred into the another places and can be used in the different purpose, like in the vehicle or in the generator set, like that. So basic reactions in the gasification side, I'm not going on that. This is very chemistry based. So these all are available in the books also and some literature also. So I'm not going in details. But only things I want to bring into you the last one, that is overall reactions. So CnHMOPSZ, these are the biomass, and oxygen and nitrogen's limited combustion is there. Some moisture is also there. So this side, this is a product of the gasifier, that is CO2, CO, H2O, H2, N2, CH4, some hydrocarbon particles, and char and tar. So these are all the products after the gasification. These are the different zones are there in the gasifier. So that is drying zone, preheating zone, oxidation zone, reduction zone, and many other zones are there. So how much air fuel ratios are required for the gasifications? So that is given here. So the gasification range is 0.2 to 0.4. So this is fueled by air less than stoichiometric combustion. So detail of gasification process is also here. So here you can see the secondary pyrolysis. There you can see that hydrogen content is there. Hydrogen is very much flammable gases, and CO2 also contains the energy. So H2 and CO is the major contributions of the heat energies. So this gasifier is like this. So it has solid fuels, solid biomass is coming. Thereafter CO, the left hand side you'll see. Then there is CO, CH4, this is coming. Thereafter air is coming from there. Then char is been converted. So there is endothermic, then exothermic reactions, and these are the different temperature zones are there. So these are the different reactions corresponding to the productions of producer gases or the syngases through the biomass. So type of the gasifier is there, that is downdraft gasifier, updraft gasifier, cross draft. There are many types of the gasifier is there. Means suppose the biomass is little bit higher in size. Okay, that is little bit 20 mm size or 30 mm size. So that can be used in the fixed bed type of the gasifier. And the types, if the suppose the rice husk is there, tremendous amount of rice husk is there, then you want to convert it to the gaseous, flammable gases. So for that, the different other types of the gasifier is being used. That is called open type gasifier. Sometimes it is somewhere it is called a downdraft gasifier. So that is called continuous type. Those which is solid types, it has the different type biomass gasifications. If the size is very small, then different types of the gasifier will use. If the small amount of the feedstocks is available, then we can go for the bubbling types. And if we want to high efficiency, then we could go for the circulating bed gasification. So there are different types of the gasifier is available in the market. In the India also there are many manufacturers also there who provide you the gasifier. So these are updraft, this is downdraft, cross draft. These are the fluidized bed gasifier. And this is circulating fluidized bed gasifier. Okay. So here there are many gasifiers I have put in front of you. I'm not going much details on you, otherwise individually it will take 1 hour. So basic purpose is that the gasification is there, gasification agent through which the gasification could be done is by air, steam and CO2. So gasifier gases is there. So what are the different possible products are there and what way we can use it? Syngas, electricity, hydrogen, Fischer-Tropsch, diesel also you can convert, methanol, ethanol, dimethyl ether, methyl ester, etc. and etc. Many types of other components could be generated after the syngas production. Either you can directly utilize syngas to an engine, or this can be utilized to another form, and that technology is called Fischer-Tropsch technologies. And from there you can convert the diesel, methanol, ethanol, etc. So this is the simple configurations of there, how this syngas has been produced. Okay. So the downdraft gasifier, updraft gasifier, and the different other types of the gasifier, which has the different calorific values. 6.21 megajoule per kg. And updraft gasifier, this can produce 4 megajoule per meter cubes, and 4.5 megajoule cross drafts. And bubbling drafts, I could not find these values. So these are the major calorific values which you can obtain from the biomass gasification. So this is the main things which you can take as a take-home message, that gasifier, how it look like. This is placed in IIT VHU, and another NIT and some other IIT is also available there. I think in Bhopal also it is present, and IIT Delhi also they are working on it, and ISC Bangalore also they are doing research on this. And we have in the IIT VHU, this is the gasifier. And from the top, we used to put the feedstock. And here you can see that there is many filtration units are there. So from the top, we put the feedstock, waste feedstocks, and filtrations is there. Then at the last, the gasifying gases, producer gases is coming off. Right. And after the gasifications, when you open it, it runs for the 6 hours. Once you load the 40 kg of the biomass in this gasifier, this gasifier cost 5 years before we have purchased this one from agro companies. It was nearby 7 lakhs total setup along with the generator. Nowadays its cost is nearby 9 lakhs. So so when the biomass is after gasification it been taken out, then remaining portions you can see here. So there is residues. So when the biomass is being gasified, then remaining amount is called char. So this char can be sold out. It had its own calorific value, and this is called smokeless coal, because gases you have taken out for the other purpose, and remaining amount of the char which is available after gasifications is like a coal, and this is called the biocoal, and sometimes it is called biomass coal, and somewhere it is called green coal. So this way, this can be utilized for the different purpose. Most of the people nowadays use in the different hotels, and in the village area, many people are using for the kitchen purpose. So that way it is used. And when you use this one, there is no smoke is coming. So this way, this is one way of the benefits. So producer gases which is coming from out. So I will tell you what is its utilizations. But when the byproduct is coming, its utilizations is that you don't have to use the raw biomass, which is dry one, which is waste. Here you are taking the gases from it, and the remaining portions is there, that is used as a smokeless coal, which can be utilized for the different purpose as a direct heating. And remaining of the gases is there that you can transfer to the diesel engine. So this here it is the diesel engine. This is Kirloskar diesel engine. Actually, this is in my experimental lab. This is R&D purpose. This is for the R&D purpose. So here you can see there is incoming. Directly you can couple it. One way, once the control unit is there, that is not mentioned over there. That is just like a valve. So how much producer gas you can input in the intake of the air, so that you can see from here. This is the T joints. So one side it is air, another side it is coming the producer gases, and it goes to the engine. So what is the benefits of the powers and related to the diesel saving? So producer gases saves the diesel. So how much diesels you can save? So once you save the fuel, once you save the economic, once you save the money to purchase the diesel fuels, automatically your economic will be increased. So this is the total setup what we have in the lab. So here this is the upper one, this is the producer gases setup, that is called gasifier. There is chiller, then there is cyclone separator is there, then filter device is there, then you can store the PG and you can utilize in the engines. And once this engines is been running, you can run it run for the electric power generations, for the pumping of the irrigations. So this way the different purpose. Once the electricity is produced with the engine, then you can use it for the different purpose. So here we have tested. This is jamun. This is jamun briquette. Jamun, not briquette. This is jamun. Pieces are there. Those has been cut out when due to the storms and air, when it comes down from the jamun tree, it's been collected, and we tested it whether the jamun wood is applicable for the gasification or not. So that we have tested. And here you can see the different portions, different cut points of the jamun and pieces are there. So this is the charcoal basically. So photograph A is basically charcoal, then burnt wood, then ashes is also there. So these are the different byproducts are there, and the gases which is coming, so that can be used in the engine. So this way we have utilized the gases in the engines, and we succeeded to reduce the consumptions of the diesel fuels. So these are the diesel savings are there. So here you can see this is equivalence ratio. Equivalence ratio is related to how much air you are transferring to the gasifier. So 0.12, 0.34, 0.36, and 0.48. So we achieve that maximum diesel savings could be obtained more than 50% at ER 0.36. This is the point. This is the point. There we have reached. Okay. So diesel saving means in 1 liter, if you have to consume for 1 hour, then only the 0.5 liter will be consumed in 1 hour. So that is the significance of this diesel saving. So when you utilize the gasified gases, producer gas in the engine, more than 50% of the diesels you can save. Another experiments we have done. So in the Kashi Vishwanath, and one temple is there nearby our Varanasi Lanka side. So
Durga Kund, sir. That is Durga Kund.
Durga Kund, yes. In the Durga Kunds, we took the different sale of this coconut, and we've investigated this one, whether this can give the producer gas for the engine applications or not. And we succeeded over it. And nearby, more than 60% nearby, we achieved the diesel saving. And this in the right hand side B, coconut char, and this is smokeless solid fuels is there. So when you burn it, it will easily burn, and you can directly heat. You can use it for the directly heating. Okay. So these are the different other figures are there. How much brake power you can find out, and because our genset is 3 to 4 kilowatt, it's power it is providing. So this is very much applicable when 3 to 4 kilowatts you are using to produce the power from an engines. Half of the diesels will be only consumed, and remaining producer gas will be utilized. So in that way, you can save the diesel fuels and relative money correspondingly. And here also we found that NOx emissions also reduces, because this is very harmful gases. Eye irritations and other harmful disease is coming in our body when you are inhaling this NOx. So this way it contributes to reduce the NOx emissions when you are using producer gas in the engine. So here we have taken in engines one parameters are there, that is called compression ratio. When you use the different compression ratio, then here you can take the diesel saving percentage volume wise. Here this is 49.05. Okay, so this is little bit corresponding to the coal gasifications we have done. Those coal which are been rejected by the NTPC, and in some villages and some small hotels, they used to purchase, and we procure from there, and we tested it for the producer gas generations. Then we could find nearby 50% of the diesels could be saved, and this is similar to the biomass. So what we could be saved from the coal, the same amount could be saved by the biomass gasification also. This is what we have proved. And these are the energies, savings are there, how much energies are there from the coals, and what are the different distributions of these coals, and what are the optimized conditions is to be taken care when you are using the engine. So compression ratio 18, 17 is more appropriate, and equivalence ratio is 0.12 has to be taken, and full load conditions, if you are using the gasifications with the engine, then this will give you the highest efficiency of the gasifier and engine coupling. So these are the different diesel fuels properties, briquette, and we have tested some briquettes also. Briquettes, what we are doing, the different biomass chips are there. We mix with the cow dung and we compress it. Then we converted it to the briquette. When this briquette also could be tested in the gasifier, then it also gives you the good results. Although this briquette, once it's formed, it could be directly used for the direct heating in place of the different wood. So briquette machines is also itself one of the very good technologies to enhance the economic of the villagers. If the briquette machines if you are using, then you are producing the briquette. This can be utilized in place of the wood for the different chulhas and the kitchens aspects, and this could be sold to the gasifier, and from there gases could be taken out. It could also be sold out.
A little interruption, sir.
Yeah.
It is so categorical and clear to all of us that we can go on listening and go on listening to such illicit topics, but we have time constraints.
Okay, I'm just finishing it. I'm finishing it. Yeah, within 5 minutes I will finish it. So this is one of the diesel saving. What we have done corresponding to briquette, mahua, coconut shell, and all these cells we have procured and we converted it to that, and corresponding diesel savings we have obtained. So these are the how the briquettes looks like. This is the briquettes, and this is the mahua wood, and this is the coconut shell, which we have tested in the gasifier. So here what we have found, the coconut shell based PG in dual fuel engines, we are found to have maximum diesel saving. Coconut is very good. What we offer in place of our gods. So that is very good. 57% diesel savings we obtain. Thereafter the briquette, 52. Then mahua wood, this is 50. So this way we can save our diesel fuels. And so I'm not going on details. So the sustainable issues and challenges are there, cost, finance, policies are there. So these are the different issues are there, and challenges are also there. So what is our strength? We have a number of, we have huge amount of biomass is also there, and some ingredients is also there, some waste materials we have, everything. So whatever things is can be burned, that could be used for the gasifications, and through that gases we can utilize in the engine, and we can save the diesel fuels. And it can, of course, it can be used in the petrol engines also. So thank you so much for your attention. So I'm very much thankful to all of you for keeping you with this time.
Thank you, sir. Thank you for being so kind as to spare your time and efforts towards this little endeavor of ours to organize the 21-day course. It was so good lecture that I hardly noticed the time is almost being over. So questions are invited from participants. All the participants are being given necessary permissions to turn on their microphones. They kindly unmute themselves and ask questions directly to our resource person. Easier for some more time. Questions from participants, please. You can unmute yourself and ask questions directly to the resource person. Yes, there is one question in chat box, sir. Devesh Kumar wants to know, how can I improve the incomplete combustion? How can I improve the incomplete combustion in bituminous caking coal briquettes?
In the gasification?
You can see the question for yourself in chat box itself, sir.
Okay, wait.
Third from right, bottom. Yes, this one.
How can I improve the incomplete combustion in bituminous caking coal briquettes? So incomplete combustions, there